Hi, welcome everybody to the 8th Scylla Summit. It's 2023, and we've been developing Scylla for a very long time, and we're excited about the content that we have to present in the following 2 days. We'll be speaking about serverless, but we have more announcements to make, and also in general, we're going to overview what we've done over multiple years, but we'll obviously focus over the last year in 2022 and describe what will going to happen in 2023. Now, outside of this keynote, we have wonderful content, probably deeper than my session, together with amazing customers and users of ours who contribute to the success of ScyllaDB. So stay tuned and check the agenda. Don't miss multiple keynotes by customers and by amazing engineers of ours. So without further ado, let's go to serverless and beyond. So for the newbies, and we have thousands of people joining us. So why ScyllaDB? Let's be upfront about it. So instead of this coming up from me, we asked the smartest entity on earth, why ScyllaDB? Which entity is that? Obviously, ChatGPT. And when we asked, we got a poem in return that almost brought me into tears. Almost, not really. But this is really cool. And AI in general is making big strides into the industry. And we have an announcement to make. As you know, we're moving into serverless, and we thought about what about AI, as many companies adopt it. So we have an announcement. Unlike many other companies, we like to go ahead and innovate, and everybody today embed AI, and we thought let's go directly into the AI-less world. So ScyllaDB wouldn't embed ChatGPT in its database. That's the first announcement we have to make. Seriously, we're very excited with our users and why ScyllaDB, instead of coming from us, see the experience that many other companies have done over the years and how Scylla contribute to their success with feature stores, with cryptocurrency, with very quick key value store, e-commerce, and so forth. Really, Scylla was born to be an operation per second crunching machine, and this is the primary use of Scylla. And I hope that you're going to learn how to use Scylla the best in the following 2 days. Now, if I'll concentrate on really technology, we used to have a phrase that Scylla provides the power of Cassandra at the speed of Redis. And really, we give you the best price performance in the industry. There are a bunch of other things that we do well that we got the design from Cassandra, like you can run as many replicas as you like, as many data centers as you like, and as many nodes and as many CPUs as you like within a single node. Everything comes out of the box automatically tuned with compatibility with Cassandra and Dynamo. No lock-in, either in protocols or in implementation. You can run it Kubernetes on-prem or in the cloud, and it's open source software as well. So let's proceed into actual content. The first part is very quick recap for newbies, and then more detailed journey of 2022 and what the future holds. So in terms of recap, as I said, Scylla is operation per second machine. We have a unique design of shard per core. This is a picture from the Linux top, where you can see all of the cores work in parallel. We actually love to see cores working for us and getting cores to 100% CPU. It's a healthy environment, and we have a scheduler that can control the allocation of what every core, which we call a shard, is doing. This was the first generation of Scylla. And obviously, we knew that there is more factors to a database, a distributed database, than performance. There's a efficiency of the different components. There is the ability to scale and to scale fast, and the influence of administrative operations that you do while you perform. So latency is supposed to be low as possible, and there is the freedom score of providing different tools in open source or open code manner. This was the first generation of Scylla. The second one was a full Cassandra API with transactions, lightweight transactions. And we proceeded to develop Scylla beyond Cassandra with change data capture and indexes and new compaction algorithms, and the alternator, which is our DynamoDB compatible API. So there's a lot of fancy features in Scylla today. And a year ago, we met around the same time frame where we launched Scylla 5.0, and we said, okay, Scylla 5.0 gives you extreme efficiency and manageability and a bunch of things easy to consume. And we talked about the future, about multi-tenancy, that multi-tenancy is coming, which will allow you to separate compute and storage and do a bunch of other things. So I'm glad to say that the future is here and we're going to cover it. So this was super fast recap for newbies about what Scylla is. And obviously, there's plenty of other sessions that you should visit. And this quick recap is really fast. Let's cover what we have done over 2022. And in 2022, I like to capture it as we expanded the capabilities of Scylla to make it an all-weather, not just a winter or summer database, but all-weather, all-terrain, high-throughput, low-latency. This is what we promise. And how we delivered, we improved performance, maintenance, and worked on serverless and a bunch of more. So let's dive in. In terms of performance, this is what you can achieve with, for example, 9 nodes doing million requests per second with P99 of 1 to 2 milliseconds. Very few databases, if any, can get to this level of performance. I must say that this is what you get with the simplified data models. The more the data model complex, then you'll get great performance, but maybe not a million with this particular setup. But this is why Scylla was invented, and this is the type of workloads that we like the most. And we've done improvements with different components that you can see on the left, starting with the I/O scheduler. So we have an I/O scheduler because every shard, which is mapped to a virtual CPU, need to run reads and writes, but also need to run a asynchronous administrative workload like streaming and repair and compaction and different other workloads. So that's why we have an I/O scheduler running within the context of every shard in the first generation to control and to give your queries a priority over a workload like streaming that needs to send multiple terabytes from one node to the next. This was the first generation, and we measured the disk performance, and we automatically gain the maximum I/O request, and we divide them equally among all of the I/O queues, which map to every shard in a 1-to-1 ratio. Later on, we figured that its life are more complicated, and sometimes if you divide the maximum I/O request by the number of shards, every shard will get too few of a bandwidth. So if it will have big tasks like compactions of large blocks, then some other queries may starve within that shard. So we allowed multiple shards to consume the same I/O queue, and then it became the scheduler work became more complicated to provide fairness. Later on, we moved through several improvements as well, and I jumped forward to version 5. Pavel and Avi, who developed the I/O scheduler, realized that life is more complicated than we thought before, and actually the disk performance is a function of also the ratio between reads and writes. We have detailed presentation about it, but we took it into consideration in version 5. We've created a token bucket protocol, and we also added I/O class throttling that in very unique cases can come into play. But usually you do not have to touch it, and it just works automatically under the hood. It's just nice to know what's in there, but things are supposed to just work out of the box. Um, we'll have a presentation about per partition limit that can assist you. Also, we worked on 30% CPU gain coming in Scylla Enterprise. It's work that we have done in 2022, and it will come into play this year. We also have a super nice presentation about distributed aggregates. So let's say if you need to do a select count, it means a full scan over the entire data set. If you'll do that assisted by a single coordinator, everything will be serialized, and that's not efficient. So distributed aggregates allows all of the nodes to become coordinators of their own ranges, and then all of the sub results are collected by a single coordinator, a super coordinator. So really nice improvement, and this is just select count, which is enabled in open source 5.1 release, but we'll propagate it into a bunch of other capabilities in the future. We also eliminated exceptions from the IO path, improving goodput, a bunch of other things, and improved the representation of range tombstones, which on certain cases were glass jaw of ours. So we improved that, making performance more stable, even in the face of range tombstones. It's most of the work for range tombstones is committed to the master branch and is propagating into a proper release these days. So that's the performance work that we've been doing. This is an example of how we test performance internally by our quality assurance team. So we're trying to constantly test a case where we have a constant throughput sent to the cluster, and in parallel, we do a set of administrative operations like replacing nodes, adding multiple nodes, decommission nodes, failing nodes, and so forth. And we compute the steady state without admin operation of the throughput of the cluster. So in add node, for example, the steady state, or in without operation, the steady state gives you a P99 latency of 2 milliseconds. And we add how much the operation adds to the latency of the, adding a node operation adds to the latency of the operations that run. And you can see here that it increases the latency by half a millisecond. I'm looking at the second line, cycle number one, node number one, latency increased from 209 to 2.79. Like really, you barely notice that. So we meet the promise of having maintenance operations while you run without any change and without going through a management window. There are cases where it's not that perfect, but we consider these cases a bug, and we constantly try to iron out these cases. And this is why we develop more generations of our IO scheduler, which V5, which is which is part of 5.1 release, and Enterprise 2020.2 is the best scheduler available in the market. So that's performance. In terms of maintenance, also important, we improved the option of tombstones. So tombstones are erased when you run repair, but there is a timer and they'll be erased whether you run repair or not. So just like that, you were forced to run repair on a weekly basis. But sometimes if there's an issue and you forgot to run repair, or you didn't schedule it, or whatever happened, you're in a risk to have data resurrection. Automatic tombstone garbage collection allowed you to forget about that, and once there's repair will run, we'll erase tombstones. And if repair doesn't run, we wouldn't erase them. As simple as that. So this is one example of improvement. Another one is load and stream. If you need to load data that resides on another cluster, maybe for migration to Scylla from another technology, or maybe in restoration from a cluster that was running on a different amount of nodes and different node sizes, then those key ranges, original key ranges, may not map the topology that you have on the new cluster. So we developed load and stream for it, and basically you can throw any SS table on any new node, and the new node will automatically go and scan through the SS table and send the partitions to the right node owning them. So this is a big improvement in maintenance for migration and restore for backup. And data restoration for backup is part of Scylla Manager 3.1, which is another improvement. Previously, backup was automated but not restore, and this simplified the restore. So today, with Scylla Manager 3.1, everything is supported. Repair-based node operation. So it's a very important feature that we released long time ago, but it took us a while to make sure that the feature works as expected, both fully stable and also with minimal effect on performance. We measured this the way that I demonstrated before by QA. So repair-based node operations makes all operations like adding nodes, removing nodes, repairing nodes, all of these using the repair protocol. So repair is a resumable protocol. So if you added a node and transfer 10 terabytes to the new node, and then you had a failure, it's okay to just, or you had to restart or something, then you can just go back to the operation, restart it, and the 10 terabytes that you already sent wouldn't be needed to be sent again. So it improves your maintenance ability once you do these operations. Life sometimes is more complicated than reality. It also makes everything consistent. Sometimes there were special cases in configuration that you had to configure in order to be consistent, and now it relieves you from any special knowledge. You just run the operation, and repair-based operation take care of that. It's also much simpler because some of the operations had to run after they ended. You had to run repair. Now, since repair-based operation uses repair, no need to run repair, so it's simpler and also faster because there's only one step and repair is running anyway. Lastly, there's a consistent schema changes, but I'll talk about it in a separate section. We also support top K queries using user-defined functions and WASM and distributed aggregates, but I won't cover it, but you can actually find how many people follow Elon Musk if you have it in your database. And there's investment in our database drivers. We heavily invest in multiple drivers, primarily the Go, the Rust that we created from scratch, a C++ driver, which is based on the Rust driver, and we're going to release in GA in the first half of this year. It's actually ready for usage in multiple cases. We improved the load balancing options. We added the serverless support, and also performance was improved. Okay, let's talk about consistent metadata. Now, metadata consistency is done by Raft. Raft is a protocol for state machine replication. So if you have multiple changes to the state by distributed group of nodes, it makes everything consistent and linearize all of these changes. So obviously, it's something good that every database should have. And before that, we had the lightweight transaction as a similar protocol, but Raft doesn't have the overhead that lightweight transaction has. Now, the main thing, Raft is just a protocol, how we use it. So we are using it for multiple goals. The first one, which I'm very happy to announce that it's getting to the default case, it's safe schema changes. If you have parallel schema changes, previously it was forbidden to use multiple schema changes at once. It can drive schema out of sync, and a manual operation would be required. This is why when we pass the Jepson test, we forbid to use the schema in parallel. And also, we forbid to use multiple topology changes at once. With Raft, these things can be run in parallel, and Raft linearize them. So in the upcoming 5.2, which is in a release candidate mode, it's default on. Previously, it was in experimental mode a year ago. It was a very complicated project, and we're in the last mile of delivering this by default. Next is already implemented, but we will only be delivered in 5.3 release, is safe topology changes. So you'll be able to add and remove multiple nodes in parallel. And this is just a beginning. With this base, we can transition to more sophisticated type of changes with consistent tables and tablets, and I'm going to provide more data about these. Lastly, in 2022, we worked on Scylla Cloud Serverless, but we haven't released it. We did release it this year. So this takes me to the future of data, of fast data, and it contains serverless and changes to Scylla Core. That's the last part in this presentation. So serverless, if you're not familiar with this syntax, it's time to go back to school. So we're switching from instances and servers to units of virtual CPUs. So we basically abstract the servers. Servers obviously are still there, but forget about what you know about instance types, about server sizes, about too much sizing prior to selection of the servers that you need to use for Scylla. Now with serverless, the building block is virtual CPU. And we also decouple to some extent the relationship between storage and compute. We still use local NVMe, so decoupling is not, it's just the beginning of the decoupling, but you do not need to think about which instances you're going to select, whether i3 or i3EN with more storage. We're doing it automatically for you with our management, which is based on multi-tenant Kubernetes deployment. And I'm happy to say that it's already implemented in the Scylla free tier. So if you go to Scylla Cloud today and you select free tier, you get 2 virtual CPUs and an amount of storage immediately. Over the course of this year, we're going to propagate it to production later on this year, and it will be staged deployment with more and more value coming to you. In terms of value, because technology is one thing, but the value is more important, it gives you beyond no need to plan much, the ability to be flexible with annual commitment with the hardware, because we also today with VMs, we buy a 1-to-1 ratio of the hardware for the cluster, and we need to annual commit in order to make it cost effective to the cloud provider. But in this mode with multi-tenancy, there is no need to commit to the cloud provider. We take the commitment and the storage and the server management, so you do not need to think about that. We also add encryption at rest and bring your own key, so it will be absolutely safe to run multi-tenancy over the same servers. Elasticity gets a big boost. Everything is API driven, and I'm also happy to say that we released an API and Terraform support for Scylla Cloud, and not just serverless, but actually Scylla Cloud VMs also get API and Terraform. This was long anticipated. Other things are also coming in terms of more flexibility for network usage and self-service for user management and billing and metering. Not directly related to serverless, but we'll lead with serverless because serverless makes everything more elastic and dynamic. So it's more required there. So we are entering the serverless world. And previously, our vision was, or the articulation of Scylla was the power of Cassandra at the speed of Redis. Now we're switching to a new era. And we also assist many companies to move from DynamoDB to ScyllaDB. And while definitely they get much better TCO today with ScyllaDB, we also like to make sure that the experience and the usability is at least as good as DynamoDB. In certain cases, it's already better than DynamoDB. There's no rate limiting per partition that DynamoDB always does, and scaling some can be faster than DynamoDB in many cases. But in many other cases, DynamoDB is better, and we like to change this equation. How we change it? So today, Scylla supports eventual consistency with regular operations unless you use LWT. With eventual consistency, everything goes to 3 replicas usually. And they may not be identical because we don't use transaction. And storage is bound to compute within the same node unless you use serverless. But it's still, even with serverless, we use NVMe and real servers, so it's somehow bound. You have more flexibility, but some bounding. And you need to repair the data once in a while. And Scylla is extremely competitive when the situation where you have high throughput and low latency, but if you have a high volume and not necessarily high enough throughput, then it becomes more expensive or together with all of the components. And we wanted to solve that. We wanted to revolutionize this. So the future coming to Scylla is based on Raft. Both the metadata and the data will be consistent. So there wouldn't be need to repair. And since there is no need to repair, data is consistent, we can just keep a single replica. We like to separate the replica from the compute from the storage. So we like to keep it on S3, but we need fast performance. So we're going to cache the data that we keep in S3 and synchronize it to S3 once in a while. This will also enable point-in-time recovery and cluster parking if you don't use and if you don't query it, and also fast disaster recovery backup. I'll explain how it is done. So how we support this vision? First, it starts with changes to key ranges. So key ranges is a range of partitions and that we manage, and every node has multiple sets of tokens. Token is the hash of a partition. So this is what the token ownership map is for every node in the cluster. We call it every token range. Basically, it's a virtual node, and it's assigned statically on Bootstrap. We manage the replication metadata by considering the replication strategy if you use replication of 3 or different one. This is the replication fact metadata, but the problem is it's quite static. It only changes once you add and remove nodes. We wanted to make it more flexible. Today, every vnode covers tens of terabytes or tens of terabytes in large cases. And we wanted to make it more flexible. So we're moving into tablets. Tablets cover also ranges of keys, but smaller ones from gigabytes to tens of gigabytes. And they're dynamically controlled and dynamically mapped. So you can think about them in using this diagram. So these boxes in colors are small tablets with data up to 10 gigabytes, and they can be mapped into shards. The shards are the vertical lines here. Now, a tablet can be splitted because we do not want to have too big of tablets in order to balance storage and also to balance CPU, and not too small so we wouldn't have too many. So tablets are dynamic. Shard can balance, or a scheduler can balance and move tablets away, which is really trivial because tablets have their own SS tables, every tablets. So it's very quick to move. We just move the ownership of the usage of the SS table within the node. You can also reshard, so you can run a server with different amount of shards, and we'll just coalesce these SS tables into fewer shards, or split the SS tables. And we can also clean up, and cleanup is just removing the SS table. We don't need to do any manipulation of the SS table today, and it's not the case in the past with virtual nodes. So this is one major aspect that will support the revolution. The second one is the future of storage. We are extremely happy with local NVMEs, but if you need to be very elastic, it takes time to scale. So NVMEs are great, but way better than EBS and Sun. But let's say if you don't use them also, and it's a high volume usage, then they can become expensive. So we went to the customers and listened to what they have to say. They actually ask for Shark with lasers, which we mapped it into. This is from Dr. Evil. If you're not familiar with this movie, also a big hole that you have to fill. So we're obsessed with customers and also obsessed with technology, and we transitioned this ask for Shark with lasers into a better generation of software assisted by object store, specifically S3. So previously we had all of these nodes, and now we have S3. And we like to have data reach the nodes and then copy it into S3 with a single copy. So on the right, this is what you get by switching to S3. S3 is almost free because compared to NVMe, it's completely decoupled from the compute. It's fully consistent because we're going to keep one copy. We're speaking about transactions or data that was repaired before we sent the SS table to S3. It's accessible by all nodes. So if you need to have an elastic deployment, all nodes can reach S3, and we can map the tablet to any node. We're going to support tiered storage. And since S3 is obviously slow, we're going to save copies in local NVMEs for speed. So you can think about a write coming to the local nodes. We will continue to have 3 replicas, and they'll receive the writes fast. But once they receive it, they can send the commit log and upload it to S3, which will help also with the point-in-time recovery. If it's consistent, nothing is needed. If it's not consistent and eventually consistent, we can run repair in compaction to send the data to S3, and then that would be it with the right path. There are many things that can improve. Compaction, for example, can happen on another node. We're going to add caching for replicas, and we can have flexibility and trade-off between the amount of NVMe caches. It doesn't necessarily even need to contain the entire data set. It may contain just the working set size. There are lots of interesting choices to make. And we're going to make it available for all users, not just the database as a service portion of delivery of Scylla, but also all of the other enterprise and open source flavors. So if we think about all of these concepts, tablet, S3, and Raft metadata, you get something which is greatest of all times. That's the future. So data is on the cheapest layer. You have caches to mitigate the S3 speed. Elasticity becomes fabulous. Removing nodes, you just need to flush the pending request on the nodes, and then you can just kill the node and transfer the tablet ownership to some other node. If you add nodes, adding hardware is decoupled from ownership. So you can add as many hardware as you like, and then the ownership of tablets propagates later. And once the first node gets ownership of the first table, it can serve request immediately. Once it receives the first gigabyte or so, without waiting for terabytes of data. So extremely elastic configuration. Also, you can back up to another data center just by backing up S3. So backup, disaster recovery backup becomes almost free, and you can park the cluster. And last but not least, I haven't forgotten also the consistency of the data path itself. Today we're moving either eventual consistency, we're moving to immediate consistency with Raft. So the configuration will be trivial. We actually have it running in a mode where it's not productized yet, but we have it running. And this allows all operations to be consistent and not just the use of LWT, which its main caveat is slow and latency. With Raft is fast and the overhead is almost not exist in many, many cases. So this is where Scylla is going. I hope that you enjoyed the presentation. We covered the 2022 achievements, which make Scylla already an extremely good database. But now we have serverless, and the future it looks extremely interesting. I hope you enjoyed and stay with us for the next session as well. Thank you.